Good morning, my fellow API practitioners. My name is Olga Podolyako, and I am a principal API architect for Microsoft Graph, responsible for Microsoft Graph API governance and standards. I am originally from Russia and moved to the Detroit suburbs in Michigan almost 25 years ago. I worked as a developer, enterprise and integration architect, and also led a cloud adoption in my previous roles. Today, my talk will be about API governance and architecture and how we at Microsoft apply the architecture method to grow and mature Microsoft Graph platform. This talk evolved from my talk at the API specification conference last year and reflects new thinking about APIs and their place in the integration space. We will begin by briefly covering what Microsoft Graph is, and we then follow with two foundational problems API governance is attempting to address. Afterwards, we will consider our solution for each of these questions. And finally, we will conclude by examining how we implemented our solution. Let me start with some information about Microsoft Graph to demonstrate the scale of the problem. Microsoft Graph platform provides access to cloud data and services across Microsoft 365 SaaS products, including Office, Teams, Outlook, Azure Active Directories, and many other products. Microsoft Graph is centered around the user. That user has multiple sets of data, including mail, task, files, contacts, available in one interconnected system. To serve our users, Microsoft Graph Platform has more than 3,500 unique resource types and more than 2,300 different relationships between them. We receive trillions of data signals from millions of our users across M365 and Teams. From inside Microsoft, more than 100 different product teams bring their APIs and data to the platform. And we have over 800 new APIs and enhancements every year. So looking at the scale of the problem, you can see that governance is challenging. Historically, we focused only on consistency of naming and vocabulary, and also predictable behavior in compliance with Microsoft REST guidelines. But as Graph platform expands and more products want to integrate with it, we, API governance, asked ourselves a question: how can we scale further? And what are our criteria for success for our platform? You may wonder, why do we ask this question? How public schools and API governance are related? Let me start with a brief story. As I have mentioned before, I live in Michigan with my family. When we had to choose a public school, we moved to West Bloomfield Township because it had one of the best public schools in our county. Anyone who lived in the city or township where a school was located could attend that school. The admission criteria were very simple. They depended on the place of residence. The academic standards, on another side, are much more complex, and they involved multiple learning objectives, benchmarking, and a grading system. Therefore, we can say that public schools have a simple entry criterion and a more complex quality criterion. Likewise, we developed a simple entry criterion for when to use APIs and more complex criteria for what makes a good API and what essential characteristics it must have for our API governance. Though these questions seem basic, they define strategic principles and form the foundation for building API governance, allowing us to prioritize and delegate API-related decisions across our federated structure and automate API compliance validation. So let me start looking at the architecture method a little bit. The architecture is a bridge between business goals and final resulting system, as mentioned in the Software Architecture and Practice book by Len Bass, Paul Clements, and Rick Kuzman. Software systems are constructed to satisfy organizational goals, and APIs are no exception. Software architecture recommends analyzing and translating business needs into a set of architecture significant requirements, which can then be implemented into a software product. These architecture significant requirements are often represented by non-functional requirements or quality attributes such as security, usability, testability, maintainability, and other entities. In addition to having a big impact on architecture and design, usually these quality attributes are difficult or expensive to change later on. Next, I will show you how we use the architecture method to define the entry criteria for graph, or when we need to develop an API. You might wonder, why do we need such criteria? After all, the more APIs, the merrier. But with the proliferation of APIs, it seems like every integration is an API, a proverbial hammer and nail. We need clear recommendations when APIs are the best integration choice. As you can see, Microsoft Graph as a cloud platform offers multiple integration options that allow developers to build people-centric productivity experiences and connect their business systems with M365 data and services. We provide granular RESTful APIs which communicate synchronously. We also enabled ETL type tool for bulk data egress. We call it MGDC, Microsoft Data Connect. We also enabled high volume ingestion of custom data into M365 compliance boundary to improve and enrich experiences like search or user profile, for example. We call them graph connectors. And finally, we support event-based integration using graph notifications. And event-based integration supports push and pull mechanism and support multiple delivery channels for these notifications using webhooks, event hubs, and WebSockets, and also event grid. As you can see, with so many options, a given business scenario, one integration option may be a better fit than the others. Based on our experience and analysis of multiple business scenarios, we identified 4 quality attributes that influence how well an integration option fits into scenario. These quality attributes for us are integration type, applications or data integration, data flow direction, data volume to process, and also data latency, if you can tolerate some time in processing of data. To choose the best option for a given scenario, we created a decision flow to guide our customers and also our product teams. This decision flow follows a simple set of questions. Basically, we start. Does your business scenario require functionality from M365? If answer is yes, then you have the only choice, it's APIs. Only APIs provide interactive functionality, access to interactive functionality for M365. If you consider pure data integration and you know how to process M365 data, then you can go further and look at the data integration options. They include and they depend on data integration flow. If you just want to ingest your custom data then in high volume, then you have graph connectors, which provide you ability to ingest your data fast into Microsoft Graph system. If you sporadically or run ad hoc want to update some data, then it's better to use Graph APIs. If you want to extract data, then you need to consider volume again. If it's a bulk extract and it's relatively time independent, then the best choice is MQDC. It's the most efficient choice. If your scenario like data leakage protection, for example, for security is really sensitive for data latency, then we recommend event type integration, event streaming, using notifications. For low volume, you have other options like webhooks or APIs. Therefore, we can conclude based on this decision tree that APIs are good fit for applications which require interactive access to M365 data and functionality and do not rely on high volume of data to extract. So as we defined our entry criteria, now we can move to defining our goodness criteria. Okay, animation here does not work. So for goodness criteria, we start applying architecture method as well. At Microsoft, we have customer-driven culture. So first question we always ask is, what value our customers will get with our product? Graph APIs as programmability surface provide value by enabling customers to build innovative solutions using Graph APIs. When customers build business solutions using Graph APIs, they expect that those APIs will be easy to adopt, secure, performant, and well supported during its entire life cycle. Effectively, it means that our customers want an API as a product. In addition, because APIs are actually cloud products, we can use established, well-architected frameworks and adopt some essential qualities, generic qualities, such as security, operational excellence, and performance. But we need to remember our organizational business needs. And for our organization, it's extremely important at this point in our API maturity to have planned, well-known releases. So we included planning as one of qualities of our APIs. In addition, we want our APIs be easy to adopt. So we enabled design quality. And design quality is responsible for making sure that APIs have consistent naming, consistent behavior. We also want to support usability of our APIs. And usability includes great documentation, great website, great learning modules. Therefore, tailoring quality attributes for APIs based on our organization needs, we arrived to 6 essential quality attributes like planning, design, security, operational excellence, performance and availability, and usability. So now what? Now we have entry criteria and we have goodness criteria. The next step for us is to socialize all these uh, criteria and principle of API governance and also build guidelines on top of that. So we have a good foundation because Microsoft published in 2016 Microsoft Trust API guidelines, which set a foundation and baseline for industry and also for Microsoft. But we need to have specific graph guidelines to talk about specific naming conventions, consistent relationship specifications, consistent error processing, and consistent error representation. We also have very specific constraints on breaking changes. We support our API, deprecated APIs for at least for 2 years, and in some cases for 3 years. We also have very well-defined structured authorization specifications. Because of all of this, we created our specific graph guidelines, but we also created a reusable library. We created a library of reusable design patterns. And here we used architecture again. We used architecture pattern language. We created patterns in the form of a solution for well-known problem, for repeatable problem in a specific context. These patterns also provided foundation to build our utility library so that if our developers and products start designing with API first in mind, they start with design of API and then they can follow using utility library service scaffolding. We also provided design patterns when to use APIs, when to use event-based integration or data connect. Moving forward. Okay, so as I mentioned before, we have a lot of new APIs and new changes every week. And we have 3 different review boards, and we have API governance as a central place to govern the process. But it's not enough. Manual verification of changes and manual onboarding won't work for us. Therefore, we have automation. For our automation, we rely on Azure DevOps. Azure DevOps platform provides work management capability and workflow capability for us. It also provides integration and orchestration with multiple tools we created to support our API developers. For example, even starting with planning of APIs, we provide integration with our tools for internal and external roadmap publishing. During design phase, we support our developers by providing linting tools, and we also work on a new language, TypeSpec, to make API design consistent, repeatable, and easy, because this TypeSpec language will basically encode standard patterns for graph APIs, and it will be like a Lego. Developers will be able to construct their design from standard building blocks reusing standard patterns. During implementation, we also provide a lot of automation and support for internal and external developers. For internal developers, for example, we provide automatic documentation generation. Documentation stub generation. We still require manual processing, but the initial structure is created based on the API description. We also, based on OpenAPI conversion, provide automatic generation of multiple SDKs and PowerShell commandlets for external developers to make development and consumption of our APIs easier. Security is pervasive across every step of our automation pipeline. During design, we start with authorization permission specification. During implementation, we all verify that these permissions do not conflict, do not overlap with other APIs. We also test permissions before we release them to the public. As we provide very rich telemetry during operation, we also constantly scan these log files to verify that permissions are not broken, that we have full coverage of API surface. We have SLA monitoring for many APIs, and we also created a KPI dashboard. And this leads us to the next topic of conversation. We defined entry criteria and quality criteria for our APIs. We automated our CI/CD pipeline to ingest APIs. Is it enough? No, it's not enough. We need to have a metric how we measure our success. Therefore, we created KPIs for each quality area of our, which we defined before. These KPIs represent the most important metric in each quality area, and they aim to foster positive outcomes for our customers. We also have created a quality dashboard to display these KPIs. This quality dashboard has views for API product teams, and it has aggregated view for our leadership. Let me give you some examples of quality KPIs. For example, for planning quality, as we talked before, it's important to have predictable release schedule to allow customers to plan for changes. For this quality, we measure the age of unpublished test APIs, which indicates how long the API is stuck in low environments. This is our current important metric and the KPI. For design quality, we want our customers to have user-friendly APIs. So we use linting exception, deviation from standards, and documentation gaps as our metrics and KPIs. For operational excellence, we want to ensure that our APIs delivered in all our sovereign clouds. Therefore, we have a metric to measure how many clouds API delivered. To move the needle further, we also work on creating a weighted API score so that we can compare APIs side by side and understand where we need additional investments in the API area. As my presentation comes to the end, I want to share main lessons learned from governing graph APIs at scale. APIs are ubiquitous, but they are not the only answer for every integration need with cloud data and functionality. You should have clear entry criteria when APIs are good integration option. When an API is an answer, then it should be treated as a software product and managed through its entire life cycle, from planning to operations and change management. Organizations should tailor their definition of API goodness for their needs and maturity level. API goodness reflects the most important API qualities for your org. Use API lifecycle automation to verify API quality compliance at every stage of the lifecycle. And finally, measure API quality and make these KPIs visible to promote and even enforce good outcomes for your customers. I hope I have convinced you that the architecture method helps in defining what is a good API, when to use it, and how to tailor API product definition for your organizational goals. Thank you so much for joining and listening.